Thank you for joining us today. This is TechWorks NC Series Nurse Call Technical Training Part 3. I am Mark Dundas, and I will be your presenter. This is a 4-part series. We are on Part 3, as I said, which is system wiring. This is a fairly lengthy presentation because it goes into a lot of detail, a lot of the options. We cover a lot of ground, so you might want to get yourself a beverage and settle in. This training is assuming that you already know what a nurse call is. We're going to talk specifically about TechWorks Nurse Call and how to design a system, how to install it, how to wire it, make it work. There is a printed handout if you want to download that and print it and make notes. There's also a test available on the content of this presentation, which goes towards your TechWorks authorization certification. Let's talk about what makes our system unique. It is a system that follows a philosophy as much as anything. We believe that less wire is better than wireless. Wireless has inherent problems with reliability that a wired system typically does not. You install a wired system and it works for a long, long time. Innovation has allowed us to repurpose the old wiring in some of these buildings while reducing the need to pull all new cable. We'll talk more about that. But we also realize that in the modern world, you want to pull something that everybody knows how to install. So we made it possible to run this system over home run Cat5 or Cat6 to save time and cost and training, because everybody knows how to terminate 568 Category 5, Category 6 terminations. The way we do this is with a unique signaling from the dome light to the control module, which we'll talk extensively about. This allows multiple calls to go over a single conductor wire. So that old wire that used to run from a dome lamp to the old lamp annunciator field on an old nurse call can communicate multiple signals down that one wire from the dome light to the control module to tell the control module what's going on in a room. Annunciators and accessories all work on 2 twisted pair loop wiring, which is our proprietary TechWorks network. We'll talk extensively about that. But again, the key here is to try to use less wire to accomplish a lot, to save money, but give you a reliable system. Let's talk about how the TechWorks system works. Whether you're using old style wire or new style wire makes no difference. The system functions the same way. It's just how the wire gets run. So from each dome light to the control module, there is a single conductor, whether that's a single conductor in a Cat5 home run, or if it's the old wire that used to run the old lamp annunciator, it's still that one conductor goes to this control module to tell the control module what's going on at that room. The power, plus and minus 24 volts, and common is common, whether it's bus on wire from dome light to dome light using the old style wiring, or if it comes home on a Cat5, the plus and the minus and the flash clock are all combined inside the control module in that case, but it still is common. The power is 24 volts DC and uses a external power supply with a wall mounting bracket to plug directly into the control module to supply power. Patient stations use 4 conductor cable from the patient station to the dome light. This was intentional. The reason is a lot of the older systems only had 4 wires in the wall, and some of them were a type of construction like wood frame construction where you can't pull new wire. So we made our stations able to communicate 2 levels of call plus a call cancel button and a call confirmation light all over that old 4 conductor wire that might be stuck in the wall. If you are using new modern wire, obviously you only need 4 conductors. It can be anything. It could be a hunk of Cat5. take your Cat5 scraps and run them down to your patient stations. It'll work just fine. Same thing with your zone lights. This again is a 3 or 4 conductor cable going out to a zone light or a group of zone lights. This could be a whole string of zone lights out here all in parallel. Doesn't matter. It's very simple wiring, and it could be any 3 or 4 conductor. What makes the difference? How many signals do you want out here on the end of this? Do you want a 2-color? Then you need 4 conductors. If you want just a single color zone light, you only need 3 conductors out there. The magic of this system and the power of expansion comes from our TechWorks proprietary network. This is something that we've been doing for many, many years with many products. And what it does is it gives us 2 twisted pair, one for data and one for power, that goes from control module to control module and from annunciator to annunciator on an addressed bus architecture. So this control module has an address, this control module has an address, this annunciator has an address, and it knows which one of these to listen to all over this twisted data pair. The one thing I will caution you is if you are running a small system with only one annunciator, this can be a Cat5 cable. I do, however, encourage you to take your unused pairs and double them up for power. So you only need the blue, white, white, blue for your data, but your 3 other pairs should be twisted together to get you as much power as you can out here to the devices out on the end of this data network. If you're going to run a whole lot of stuff together and a whole lot of devices out there on the end, we encourage you to use a 2 twisted pair number 18 cable here. Just save yourself the grief and get enough cable out here so you don't run out of power. Let's talk about standalone rooms, because this is one of the unique things about our product. Our NCDL, R, W, or B, red, white, or blue, SCT, is a standalone control module. What that means is that if you just add local power to that dome light and set the dip switches correctly, you don't need a control module. It is the control module. It's got its own built-in flash clock. It can do everything that you need to have a complete system out here at a room with nothing else. That's all there is to a system. We're the only ones that I know of that can provide a single station with a single dome light and be UL 1069 approved. Let's talk about old wire. Loop and power are, the power and the flash clock, I should say, are looped. So this right here is your 3 conductors that loops from dome light to dome light. That's the way the old systems were wired. Power, plus and minus, and a flash conductor were on a 3 conductor cable that went from dome light to dome light to dome light down the hallway. There was a single conductor home run that used to be to a lamp annunciator. We intercept that old wire and hook it to some screw terminals here on the control module to communicate what's going on at each room to the control module. This was the way Roland, Duquesne, and Executone wired their old systems. It'll work just fine on that old wire, as long as the wire still has integrity. If it's been chewed by mice or burned in a fire, well, obviously you got jacketing problems and you've got problems. But if you've got a clean old installation, especially if you know what that wiring is because maybe you put it in, it can be reused. Let's talk about home run. So on modern installations, you can run Cat5, Cat6 home runs from each dome light to the control module. Make it simple and easy. Just one home run from every dome light to the control module. It can also work for your annunciator wire, as I said. Just make sure you double up those spare pairs. This is typical of the construction today in day surgery, skilled nursing, rehabs, and assisted living. Very simple, very cost-effective. The power of the TechWorks network is that it allows us to have all of these devices communicate over that twisted pair bus, 2 twisted pair, one for data, one for power. You can expand the system as required. So 16 control modules, each with 16 inputs, equals 256. So this data being shared, connected from device to device to device, allows you to get to 256 devices on one system. You can run repurposed wire, as I said, over here on these connectors. We'll talk more about it. Or you can run Cat5 home runs to these Cat connectors. They're all built into the control module. Everything's there. This system, because it's address, so this box has an address, this box has an address, this box has an address, this box has an address. So every control module has a unique address on this bus. That means that the annunciators can be segmented. If you've got a simple system, and this is a 32-point annunciator, but let's say you had a 16-point, you could run a single Cat5 over here to a single control module, set the address the same. So make this address 0, this address 0, and this control module will relay everything to this annunciator. However, when you have two control modules and a 32-point annunciator, this control module illuminates the first half of the annunciator, the first 4 columns. This control module would be the next address in sequence. So if this is 0, this would be 1. This would be 0 on this half of the annunciator, and address number 1 would be the right 4 columns. You can also wire local zone lights. We'll talk more about that, and duty stations to the outputs over here on this corner of each control module. Let's talk specifically about the power of the NC-SDS, and it could be an R, a W, or a B SCT dome light. This X represents the color. As I said, it could be an R, a W, or a B, red, white, or blue. But the S is for screw terminals for old style wiring, and the C is for Cat connector, and the T is for tone. So if you have a color with SCT on the part number, you've got it all. You've got everything you could possibly need in this dome light. We do make another version of this dome light that does not have the S and it does not have the C. So if it's a WC, it means it's white and it only has that Cat connector. It does not have the old wiring screw terminals, and it does not have the tone, so therefore it doesn't need the dip switches. These dip switches aren't there. So that's the significance of the part number. This is a room controller. It is a single color, 2 station. That's what the 1-2 means. 1 color, 2 stations. Wiring options, Cat5, Cat6, or old style wiring. Standalone or a system. This is how you determine how it's going to communicate. This little legend is on every dome light, and it tells you how to set these dip switches to make this thing function the way you want. Tone is one of the dip switches, and you simply turn the tone on or off. Everything on this dome light is dip switch configurable as long as you order the SCT part number. So the control module wiring to an NC-SDS, this would be an R SCT. Let's say you're using the Cat5 connector. You've got an RJ45, and we recommend wiring to TIA 568B. If you're using repurposed wiring, you've got a bus in and a bus out. The bus in is 24 volts DC common and your flash from the control module. Again, that flash keeps all the dome lights synchronized so they blink at the same rate. It doesn't look like a fire truck coming at you if you look down the hall. All the lights are synchronized. On the output, you have the same 24 volt common and flash, but you also have a signal wire. This signal wire is the current source. What that means is that different calls have a different current flow. If the dome light is sitting there off and working correctly, it has a current flow output to the control module. Because it's a current source, it doesn't care about the gauge of wire. It doesn't care about how long the wire is. So you don't have to worry about voltage drop. It's a current source, which means that these different current levels tell the control module what's going on. If there is an N call, a slightly higher current is sent down this wire. If it's an E call, it's a slightly higher current flow. And if it's a code blue call, it's an even higher current flow. When you hit the cancel button on the stations, it sends that station back to the neutral or off position and changes the current flow to that control module, telling the control module, hey, I got a working dome light out here, but I don't have any calls. Specifically on the RSCT, to wire up your stations, you have 4-conductor wire. Now, this 4-conductor wire can be anything. It could be old thermostat wire. It could be Cat5. I don't care. It doesn't care. You've got 4 station terminals here that are simple contact closures. So if you make a contact between common and N call, common and E call, common and cancel, you can turn this dome light on and off just like it were a station. You can get really creative with what you can do with this thing. The key is that once a call has been started by a contact closure, you need this cancel wire and a common to be able to reset this station and to provide lamp annunciation at the station for call assurance lights. So a steady lamp sends an N call. If you place a contact closure between common and E call, you get a higher current to the control module. And if you do a contact closure between common and cancel, it resets the station. Let's talk about code blue. The NC-DL12BSCT would have a blue element. All calls need to have a local cancel button. So this cancel only button would be used with a code blue kick plate, for instance. It has everything in it to talk to the dome light and provide the call assurance light to the user. The kick plate only has a contact closure on the back of it, which goes to the station terminals on the back of this station. So you just simply hook the contact closures between the N call or the E call. Typically, it's going to be an E call because it's code blue, and the common. Station, the cancel only station circuitry handles all of the call confirmation and tells local staff this is the station that is active. So you need one of these. Remote cancel station wiring. This is if you have a station like our NC-VP-SAS-RC, that means that somebody doesn't want the cancel button on the station. They want to remotely cancel this. This happens in mental health. You only have a call button on this station. Outside of the space, they typically have a key switch or a button with a light that tells staff, this is your call, this is your station that's activated a call, but this screw terminals out here allows you to add whatever hardware you want to reset that station. If you have a standalone restroom and you want to add a slave, you can do that. So you've got a pull station hooked to your dome light. This device always hooks to the station with the power supply. Then you have a station that is your slave. This might be by a receptionist or some other location that needs to know that can't see this dome light outside of the restroom. You need 3 conductor between the 2 stations. You make the dip switches on the one with the hardware hooked to it, meaning the pull station and the dome light hooked to the power supply, that becomes the master. This is the one with the flash clock. This is the one with all the control circuitry. Then you come over here to your remote annunciator and tell it to be a standalone slave. Okay? And all you need between the two is 24-volt common and external flash. This wiring looks like this. So you could have this hooked to a control module. At that point, your control module could be hooked up over here, or it could be hooked up via your Cat 5 home run. Makes no difference. This one happens to be shown as a Cat 5 home run. Then to have a secondary dome light, you simply come off of the screw terminals over here, the output of the one again with the station hooked to it. So you got to have that one with a station hooked to it. That's the one that hooks to the control module. That's your master. Then your secondary annunciation location becomes a slave. That's the one that gets that up with the slave dip switches. So the critical part is the one with the hardware is a master, 3 conductors in between, and then set the secondary light as a slave. Now you can go on out from here to other slaves. You can do this up to 4 different slaves on here. Just everything from here on out is a slave. So let's talk about the NC-DL22, which is your new room controller, but it's different. It's got 2 colors, 2 stations, but you have wiring options. So on the NC-DL22RW, it is different than the code blue dome light. The NC-DL22RW has both a Cat 5 connector for modern wiring and old style system wiring. The NC-DL22 only has a Cat 5 connector. It does not have old style wiring accommodations. It does, however, have something the NC-DL22RW does not have, and that's screw terminals to activate these lights as a zone light. You simply hook these up screw for screw to the zone output on the control module, and you get a zone light. You don't need to set any dip switches. You don't need to do anything. We made it real easy for you to use this dome light as a zone light. The NC-DL22RW wiring and signaling is the same as an NC-DL12. This is just, remember, a 2 color. So you got the Cat 5 as TIA 568B. You can use repurposed wiring to bring your bus in, bus out, bus in, bus out. Then you've got your signal over a single conductor. This is just like a DL12 that we talked about previously. Your station wire comes in from the station over 4 conductors. Very simple, could be anything. You've got a common, an N call, an E call, and a cancel. Just like an NC-DL12. The difference with the NC-DL22C, BR, blue-red, or BW, blue-white, is that it does not have that old wiring. It's slightly different. You've got only a Cat cable home run, again, TIA 568B, no repurposed old style wiring. That is not an option. This connection right here is for a zone light, and you can parallel up to 4 zone lights off of a single zone output. Very simple to hook a zone light. You've got power, you've got the top element, you got the bottom element, and you got common. And when we get the control module, we'll talk about how you set this up so that you can have different signals out of the top light or the bottom light. Station wiring is exactly the same as every other station wiring. You got 4 conductors. Your station terminals are exactly the same. You got common, end call, e-call, and cancel. Now let's talk about this control module, because this is where the magic happens. You've got 16 RJ45 connectors for cat cable, one home from each dome light. You've got screw terminals for old purpose wiring. You've got your network wiring terminals for your TechWorks twisted pair network. You've got your network address switch. You've got individual switches to put stations out of service. Why would you want that? If you don't have something plugged into one of these connectors and you've got supervision turned on, you are not going to be able to live with your system, because the ones that don't have anything plugged into them are going to sit here and blink and squawk at you, telling you you've got a failure. So you want to go over here and you want to turn these to the inactive position so that it will ignore any unused jacks. Same thing with these terminals. If you're not hooking something up to a terminal and you've got supervision turned on, you have to turn that input screw terminal off so that it will get ignored. Zone output, you've got two connection options. You've got an RJ connector, or you've got screw terminals. Now, I'm going to warn you, some of our older dome lights, when we first came out with the latest version of this control module, which went to 4 screw terminals, the dome lights didn't catch up right away. So this connector is connected at the control module, but not at the dome light. You can use Cat5, plug it in here, but at the dome light, you got to break it out and use the conductors out of the cable to hook it up. It's probably much easier to just come off of the screw terminals on both ends if you're using one of the older style dome lights. However, all of the new NCDL 2.2 and 1.2 will have the ability to run everything over the Cat5 cable from this connector to the connector on a dome light. Just got a little ahead of ourselves for a while, so you may have experienced a situation where it didn't work. This is zone 2 output. This is where you configure it. We'll talk more about this in the next section of this training, which is the programming and how to set these up. But basically, you have 16 switches that correspond to your 16 stations. And if you turn these on, it sends a signal from this dome light out this zone port. Zone 2, same thing, individually selectable. Any one of these 60, any one or any combination of these 16 out zone 2. Power is, as I said, 24 volt DC. You've got 2 barrel connectors to plug them in from the power supply module, or you can run 24 volts DC into these screw terminals or out of these screw terminals to another control module. 2 ways to wire a system: individual Cat5 home runs. These wires here go directly to a RJ connector. If you look into the Cat5 from the dome light to the Cat5 connector here. As I said, some of the dome lights got out there and there is an incompatibility. When we went to this control module version, at first the dome lights didn't catch up, but that's caught up. Now you can use the RJ connector on the dome light as well. Or you can use that repurposed wiring. So you got the bus wiring goes to here, that's your power. You got your station wiring, which is that old repurposed Annunciator lamp field wiring to these screw terminals here. Wire from the dome light is a 3 conductor, 16 to 18 gauge minimum to be able to drive all those lights out there in parallel. Your screw terminals are plus 24 common and flash. Your signal conductors can be anything. They literally can be any kind of wire that was in the building or that you want to pull. If you want to run the wire this way, it doesn't know if it's old or new. These are the old Annunciator lamps. You got to disconnect them from the old lamp field and repurpose them and connect them to the control module here. Or you can do a combination of these two topologies. If you've got some of the old style stuff in a building and you can't or don't need to replace it, you can use any of the unused ports and run Cat5 to them. The system does not know the difference. You can run to either one or both. They're all active. So let's get familiar with the output devices before we talk about how to wire them. You got a few options. One of the options is our TechWorks network devices. This would be your NC-AN16CT, which is a 16-point annunciator with built-in tone. Very easy to label. All of our annunciators are very easy to label. This Lexan front just snaps off of here. You got some tabs, you pull, kind of squeeze it, and it comes out of there. In behind is just a piece of plain white paper. You can use your computer and program. We can provide templates, and you run that through your printer and print any label for any of these spaces that you would like. They could be colors, red, blue, whatever, and they can be labeled to represent whatever the end user requires. They also make the 32-point, smaller window, twice as many lights. Again, built-in tone, same, easy to label. We provide a template. For zone outputs, you have a couple of options. The NC-SDS staff duty station with tone, and it has a lighted silence button. So when a zone alarm goes off, you get a tone and this silence button lights up. When you press the silence button, it turns off the tone, but that is a toggle. If you push it again, the tone will come back on. If there is still a call pending and you've silenced the tone, the light stays on to tell you that the tone is off, but the station is still active. If there is another call comes in, this station will automatically start sounding again to draw your attention to another call on the system. If you silence it and a third call comes in, the tone will still come on. If the station is turned off because all calls are inactive, the next time a call comes through, it will once again sound the tone and light the light. So you don't need to worry about turning it off and forgetting to turn it back on. Two different dome lights that can be used as a zone light. This is the NCDL12 RSCT. Of course, again, this comes in blue or white. So BSCT or WSCT if you're representing a zone with code blue or some generic. The key is that whenever you do this, you have to set this up as a slave. You have to order the one with a tone in it, and you have to set it as a slave. We also have the NCDL22, which does not come with a tone, but it can be a two-color zone output light. Comes complete with the interface to do that. Annunciator wiring is that two twisted pair magic network that goes from control module and from control module to annunciator. On small networks, the wire can be Cat5. On large networks, we prefer that you use an 18 gauge two twisted pair. Your terminations are transmit, receive, and power, plus and minus 24 volts. This is how you connect between the control module and the annunciator. The exact same screws appear on the back of the annunciator that appear on the control module. Everything is in parallel. So if you've got a dozen annunciators, you take the same two twisted pair and go from control module to control module, from annunciator to annunciator. There is no magic. Nothing is home. It has to be home run. It could be home run. You can run the wire any way you want. So the thing about a twisted pair network is you need to turn the terminator on. This is one of the selections on that control module that we'll talk about in the next section in programming. But the key to good data communication is first, you have to use twisted pair wiring. You can run this wiring with the TechWorks network any way you need to run it. You can have short branches that go off to other devices, like from control module to control module. You don't need to turn the terminators on there. You could bring them all together in the center. They'll all talk. This one will talk to here, this one will talk to there, this one will talk over to there. The key is that on your longest runs, you want to turn the terminating resistor on the control module or the annunciator. They both have them. All the devices that have data terminals, our TechWorks network data terminals on them and can connect to this wire, they all have a terminating resistor built in. Turn it on only on the last device on a long run. If you turn it on a branch feed, it will block the communication. It'll essentially cut the wire right here. So this device can talk to everything this way and everything this way, but devices over here can't talk to devices over here. If you put a terminator on this short run, it'll block the network. Don't want to do that. So only the long runs and the ones that have one set of wire out here on the end of a run. Let's talk briefly about the IMR, because this is a very powerful tool that can be added. It is not part of the UL 1069 listed system. However, it can be added to the system very easily. Why would you want to do that? It adds pocket page. It can add tablets as annunciators. It can send text messages. Custom text can be added to any button in the system. So any room bed call, any toilet emergency call can have a separate message that identifies that room and that button. It can also be sent to any phone, any carrier, or multiple phones, multiple carriers. So that one message from that one room can be sent to multiple people on different kinds of phones all at the same time. It doesn't care. We can also do digital signage using the IMR. We can put a graphic wall display up on the wall and light these colored lights all over this thing that represent what's going on in the system. What's critical about it in this presentation is the wiring. This is your IMR. It connects to your network with a simple patch cable into your router. That turns any PC into a display terminal or a workstation. This is determined, the functionality of whether it's just a display or if it's a workstation is determined by the password and the user credentials. So you log into your terminal and you only see what you're supposed to see. You only have the functionality of the things you're supposed to be able to control. The IMR connects directly to our TechWorks data network, whether this is a clinic room status system, our CC series, or if it's our NC series, it goes on that annunciator line on the NC series. So that twisted pair that runs from the control module to the annunciator, just extend that over or connect it directly right here at the control module. Put them both in the back room. We don't care where this thing lives. Put it close to wherever the network equipment is to make your life easy. Just run your two twisted pair over there and hook it up. It's that simple. Connects directly to any annunciator line. You can do both at the same time. That's significant. If you have a clinic with workflow, room status, and a nurse call, a single control module, meaning a single IMR, can talk to both systems. You don't need to put in two IMRs. You can run one IMR can talk to both of these. Again, it runs on 24 volts, just like everything else, so you can share power supplies. All you have to do is plug it in. That's the beauty of the IMR. Plug it in. That's all you got to do. Zone output wiring. This is your 3-conductor to a duty station. We'll talk more about how to set that up functionally in the next section. These zone control, or these option switches, control what comes out of this zone from the standpoint of emergency calls versus normal calls, et cetera, et cetera. You can also run all 4 conductors from these 4 conductor screw terminals out to one of our NC-DL22C code blue dome lights, and it will automatically become a zone light. You don't have to do anything else. However, again, how you set up these configuration switches determines what shows up on the blue light and what shows up on the white light. You can control that. 2 discrete zone outputs, zone 1, zone 2. Station zone assignments are individual by dip switch. So what comes out this set of wires to this duty station is controlled by turning on and off these dip switches. You've got 4 conductor cable. You only need 3 for a duty station, 4 for 2 color options. Your screw terminals are 24-volt DC, code blue, emergency and end call, and common. So that's the basic configuration. And then by changing these, you can kind of mess with whether it's code blue or e-call on the top color and e-call and end call on the bottom. Why would you want to do that? Because this device doesn't have 2 colors on it. You need to be able to have a way to set this up to communicate a lot over a single wire. Up to 4 devices can hook together in parallel. So if you need more zone lights off of this zone, you can hook them in parallel. If you need more duty stations, we had one guy hook up a whole bunch. I want to say a dozen or more duty stations. We designed it to really only drive 4, but it really doesn't know the difference. If you're going to drive more, you're probably going to want to use bigger gauge wire. That's all. Just make sure your power gauge is big enough to drive more than 4 devices. But 4 devices will run on cat connectors, cat cables. Zone wire from a NC-DL12 RSCT. This is a very common use of this device. You've got your 3 conductors coming in, power, and you can hook to either the code blue or the end call terminal, and common. Again, depending on how you set those configuration switches, you can send all of your signals down a single conductor so that this thing can display all calls in a zone or just emergency calls in a zone, depending on what you want coming out of this zone light. You always set a RSCT or WSCT as a slave. If you're going to extend it to another, all you have to do is run 3 conductors from the output terminals to the next. These dip switches are critical. The wiring here is simply 3 conductors to 4 different devices. Connection of the dome light is always 3 conductor cable with a 1-2. With a 2-2C, it is 4 conductor cable. That's the difference. You have to go to 4 conductor cable to get your plus minus, your code blue, your end call, your e-call, your common, all that stuff out there. You got more communication going on. Connections are screw terminal at this time. You will be able to go Cat5 to Cat5 with the newer dome lights as soon as the newer dome lights are out there. Probably already shipping, but that's the difference. The old dome lights, when we came out with this new control module, did not have the connectivity. It's hooked up on this end, but it wasn't hooked up in the dome light. A little bit of oversight on our part on shipping product. Still works though. Zone and duty stations. So here's a RSCT dome light running on 3 conductors. You can sound a tone whenever a call is active on the system. You get visual call indication either on the dome light or on the silence button on the duty station. You got a distinctive silence button. This thing lights up. That's how you know there's a call, even if you silenced it. You turn off the tone, but the light stays lit. It's a toggle, so you can turn the tone back on if you want to, but it will automatically turn back on when the next call comes through. So if there's one call pending and you silence it and another call comes through, it will automatically reset it so the tone will start on the new call. All these stations are moisture resistant, especially this one. Very easy to clean. And again, uses just 3-conductor cable for full functionality. More tools online 24/7, 365 at techworks-usa.com. You can find brochures, architects and engineers specs, all kinds of wiring diagrams and things to help you. We also are always here to help with design assistance or quotes, any kind of technical assistance, but hopefully you've watched this video series and read the installation manual before you call. We're always here for tech support, always here to help engineers and architects implement the right parts and pieces for their project. Thank you very much for your time today. Next up is part 4, which will cover system programming.